Imagine walking into a Cambridge mathematics exam not as a stressed-out student, but as a master strategist with the absolute perfect blueprint to crack the vault. That's what we are doing today. We are looking into one of the highest value, yet most misunderstood and frankly, poorly executed topics in the Cambridge 9709 syllabus. I'm talking about the numerical solution of equations using iterative methods, specifically the equation where xn+1 equals f of xn. Now, listen up, because if you are taking syllabus codes 0580, 0606, 4024, 4037, 4040, or 9709, this explainer right here is literally your skeleton key. It's the master plan to assemble your cognitive skills and pull off the perfect answer heist. But before we get to the vault, I need you to do something crucial. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Let's dig into this masterclass and see exactly how we can secure every single one of those method marks.
Okay, let's dive right into the core problem. Why do incredibly smart students consistently bleed marks on these multi-stage xn+1 equals f of xn questions? Well, let's look at two classic profiles we see all the time. Let's call them Alex and Sam. You can see their flawed answers right here, completely covered in red pen marks from the examiner. On the left, we've got Alex. Alex overloads the answer with raw mathematics facts and endless calculator outputs. There's zero analysis, zero intermediate steps labeled. It's just a data dump, resulting in a painful 1 out of 3 marks. Then, on the right, we have Sam. Sam completely rushes the job, misses the command word requirements entirely, and just scribbles down messy numbers without any clear labels or logical flow. Here is the kicker, guys. They both actually found the right final number, but they completely failed to show the step-by-step reasoning that examiners are actively hunting for. They tried to grab the cash without disabling the alarms first.
I want you to really let this quote from a senior Cambridge examiner sink in. Most students lose easy marks on iterative methods, but after this, you won't be one of them. This perfectly sets the stakes for our heist today. The difference between an A and an A star doesn't come down to knowing a secret formula nobody else knows. It comes down to capturing these exact method marks that everyone else is carelessly throwing away. It is not just about finding the root of the equation. It is about proving to the examiner that you understand the mechanics of the iterative process. What we are uncovering in this session is a highly specific, tested strategy to capture those exact marks. You are going to learn exactly what examiners want to see on that page and how to structure your reasoning to deliver it flawlessly every single time.
To pull this off, we need a highly organized step-by-step approach. Here is our masterclass syllabus for the heist. First, we'll dissect the iteration mark trap. That's the security system most students trip over. Second, we'll build the core theoretical foundations. Third, we'll map out the procedural framework, your exact step-by-step route. Fourth, we'll review critical examiner warnings so you know where the traps are hidden. And finally, we'll execute the evaluation and exam strategy. Let's keep moving.
Section 1, the iteration mark trap. Let's start with the trap itself, because it catches so many brilliant students. Why do they fall flat here? Because they treat an iterative formula, let's say something like x sub n plus 1 equals the cube root of 5 minus x sub n, as a purely mechanical calculator exercise. You punch it in, hit equals a bunch of times, and boom, there's your answer, right? Wrong. That's the trap. When the exam paper explicitly says use the iterative formula, it is an instruction to demonstrate a process. The examiner doesn't care that your calculator works. They need to see the machinery working in your head. They need the cascading values of x1, x2, and x3 written out explicitly on the page. If you just write the final numerical answer, you have entirely missed the critical process marks. You've shown them the open vault, but you haven't proven how you picked the lock.
Let's move to Section 2, Core Theoretical Foundations, and see how this builds. To completely bypass that trap we just talked about, you have to understand the underlying principles of what you're actually doing. The assessment objectives for iterative methods aren't just testing if you can push buttons. They target distinct cognitive domains: knowledge, application, and analysis. You aren't just crunching random numbers, you are analyzing a mathematical sequence. In fact, principal examiner reports consistently highlight that candidates who successfully reference cross-topic connections, like relating this numerical iteration back to the visual intersection of two graphs, achieve significantly higher grades. Why? Because it shows absolute mastery of the mathematical architecture. It proves you see the big picture.
Think of an iterative method as a theoretical architecture. It's essentially a feedback loop. You take an output, feed it back in as the new input, and watch what happens. The precise definition relies heavily on the concept of convergence. You are mathematically proving that as n approaches infinity, the sequence zeroes in on one single specific root of the original equation. Again, if you just write down the final converged answer, you've shown the destination without the journey. And in these high-level Cambridge 9709 papers, the journey itself is precisely what is being assessed. The journey is the math. The destination is just a byproduct.
And this table right here brilliantly illustrates exactly how you are evaluated across those three cognitive domains: knowledge, application, and analysis. Now, I'm going to share a secret weapon that top students use to hit all three of these domains simultaneously. They adapt the Peel framework: point, evidence, explanation, link, which is normally used in essay writing, and apply it directly to mathematics. Think about it. Point, you state the initial value. Evidence, you substitute it into the formula. Explanation, you show the subsequent clearly labeled sequential steps. Link, you provide the final converged answer to the requested accuracy, linking it back to the command word. It is a foolproof, structured way to hit every single assessment focus. Now, before we continue and look at how to actually write this out, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 3, the procedural framework. Now that we know exactly what the examiners are looking for, what is the actual procedural framework? What is our heist plan? Let's see how those lost marks from Alex and Sam's disastrous examples earlier can be completely transformed into full credit using a highly structured methodology. I'm going to show you the exact blueprint for extracting every single possible method mark from these questions.
Right, let's break down this 5-step procedural sequence. This is where those red pen marks transform into green check marks. Step 1. Deconstruct the command word. If the question says use the iterative formula to find the root correct to 3 decimal places, underline iterative formula and 3 decimal places. Step 2. Extract the relevant data, like your starting point, say x0 equals 2. Step 3. Select your analytical framework, which here is the sequential listing method. Step 4. Execute with clear notation. This is exactly where Sam failed. We must explicitly write out x1 equals f of 2, keeping the full calculator display for our intermediate steps. And finally, Step 5. Present the final root with the correct terminology, rounded to the requested 3 decimal places. Applying these strict presentation conventions completely changes a messy 1-mark answer into a perfect 3 out of 3.
I really need to reinforce this concept, so we are calling it the method mark strategy. Marks are awarded for the process. Proper headings mean actually labeling x1, x2, and x3 on your paper. Don't make the examiner guess what those floating numbers are. Accurate formats mean keeping your intermediate steps to at least 1 more decimal place than the final requested answer to avoid rounding errors. And clear annotation means distinctly stating your rounded, final answer at the very bottom of the sequence. Remember, the journey of solving the equation is just as vital as the final answer itself.
We are now entering Section 4, Critical Examiner Warnings. We are pivoting to Examiner Alert Mode. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's look at where past candidates have actually triggered the exam alarms. I'm going to rapid-fire the top 3 mistakes pulled directly from the principal examiner reports. First, confusing cause and effect. This looks like trying to algebraically rearrange the formula back into the original equation instead of simply running the numbers through the iterative loop like you were asked. Second, forgetting format and presentation conventions. This is the classic data dump, leaving a huge string of numbers entirely unlabeled so the examiner has to play detective to guess which step is which. Third, providing generic answers instead of linking the math back to the specific context. Okay, I'm putting 60 seconds on the clock in your mind right now. If you were looking at a complex mathematics data chart and you had to extract the core trend, you wouldn't just list numbers, right? You'd explain what they mean.
Now, what's really interesting about this slide is how clearly it contrasts a totally flawed response with an ideal one. Let's do a quick find the flaw challenge. Imagine a student writes this paragraph. The sequence didn't work because the numbers got too big. Can you spot the flaw? Exactly. It is completely generic. It earns 0 marks. A top-tier, context-specific answer, using our Peel framework, would instead say something like, the iterative sequence diverged because the initial value was outside the domain of convergence, as the gradient of the function is greater than 1. See the difference? It uses authentic terminology and explains the highly specific mathematical cause and effect. If I gave you 30 seconds to speed write a perfect paragraph, that is the level of detail you need to aim for.
We are finally at Section 5, Evaluation and Exam Strategy. This is the final stage of our heist strategy. We've bypassed the traps, we've cracked the lock, and now it's about high-level evaluation and executing the perfect solution to get out cleanly with maximum points.
Top-scoring candidates execute what we call a deconstruct, solve, evaluate loop. Step 1, identify the given information. Step 2, break the iteration down into logical, manageable steps. Step 3, solve systematically by writing down every single iteration clearly, just like we practiced. Step 4, check for reasonableness. This is huge. If your iteration suddenly bounces from 2 to 50 to -400, check your calculator input. Something is wrong. And finally, Step 5, make justified recommendations. For example, if you are asked to verify a root by a sign change, you need to evaluate the function slightly above and slightly below your final answer to definitively prove the root lies within those bounds.
To truly master the assessment objectives in the 9709 syllabus and secure that A-star, you need higher-order evaluation. You must start questioning assumptions. For instance, does this specific iterative formula always converge? Considering different perspectives means recognizing that an equation might have multiple roots, and your chosen starting value x0 dictates entirely which root you're going to find. Justifying decisions with evidence means explicitly showing your intermediate unrounded values before you state your final root. Identifying these limitations and understanding alternative interpretations pushes your answer from good enough to absolute perfection.
So, the crucial point of this whole explainer is this cheat sheet recap right here. Look at that progress bar reaching 100% mark potential. The perfect answer follows a completely standardized sequence every single time. First, identify the key elements and decode the command words. Second, apply the correct principles, like our PL framework. Third, execute the analysis with crystal clear working and notation. Fourth, verify the results for reasonableness. And fifth, present in the appropriate format, respecting decimal places and proper terminology. Sticking strictly to this timeline is the time management matrix that absolutely guarantees maximum method marks.
We've officially cracked the vault on numerical solutions. By respecting the method, you turn a simple calculator exercise into a rigorous, undeniable mathematical proof. But understanding this process leaves us with an interesting final thought. If a single slight adjustment to our initial starting value can completely change which root the formula discovers, or cause it to spiral out into infinity entirely, how much of complex mathematics is really just about finding the right place to start? Are you ready to stop losing easy marks and execute the perfect method mark strategy on your next paper? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Until next time, keep questioning the numbers.